This is the video lecture for section 8.1, which is about the distribution of the sample mean. So first, we're going to talk about how we create a sampling distribution. So the sampling distribution of a statistic is a probability distribution for all possible values of that statistic, whatever it may be, computed from a sample of size lowercase n. So the sampling distribution of the sample mean, x bar, remember x bar is what we use for the sample mean. So the sampling distribution of the sample mean is the probability distribution of all possible values of the random variable x bar computed from a sample of size lowercase n from a population with mean mu and standard deviation sigma. So you should remember x bar is always sample mean, lowercase n is always the sample size, and the population mean is that funny Greek letter mu, and the population standard deviation is always that funny Greek letter sigma. So what is the idea of a sampling distribution? The idea is first we get a simple random sample of size n. Then we want to compute the sample mean for that sample we just took, which is x bar. And assuming that we're sampling from a finite population, we keep doing steps A and B until all distinct simple random samples of size n have been obtained. So it's important to note here that once we've gotten a particular sample, we cannot get it again. However, if we sample and we get thing A first and we get thing B second, that is different than if we pick B first and A second. So, as always, we need to talk about a little notation. The mean of the sampling distribution of the sample mean is denoted by mu sub x bar, and the standard deviation of the sampling distribution is called the standard error of the mean, and it's denoted by sigma with an x bar. So the subscript just tells us that our mean is for a sampling distribution of the mean, and that our standard deviation is the standard deviation for the sampling distribution of the mean. So now we need to do the sampling distribution activity. That was also posted for you in Momentum, and we will cover that completely in another video.